What's the first thing we're going to do when we ask this question here? What's the first step? Pit. Draw a diagram. I'm going to draw a cannon because that's just the best way to ship it. What's up? Please and thank you. Kelsey, what's up? I'm sorry, I can't hear you.
Yes, she's on.
All right. Cannon, firing out. All right. What are the things that we're looking for to identify in this problem? Could be already. What are the things that we're trying to identify in the problem? Maximum height. What else? Time. And not only just time, we're trying to look at that time at this point right here. T final, T max, whatever you want to call it. Okay. What else, sir? Yeah, you already. Range. Range. Range is going to be from the starting position to the final position. All right. At least now we have an idea of what it is that we're looking at. Okay? So what's the next step? Given. So what's the given information from the prompt?
12 meters per second.
All right, and what is that equal to?
It's not like the time. Or sorry, no, not the time. Sorry.
Okay. Our initial velocity.
I'm sorry. I did screw.
What else do we get in this prompt? The angle. What is the angle?
45 degrees.
Okay. That's the Greek letter theta. Okay, it just means the angle. Okay, we're going to pop that in just a minute here. What else is inherent to the idea of this question right here? What else? This is on Earth. So what else do we have acting? Gravity. Okay. That seems like that's about all we need, isn't it? Take a look at our equations that we had to solve these problems. That's about everything we need. We got V naught, initial velocity. We've got gravity. We've got theta. When I'm going to go through this, when I'm going through this, I wanted you guys to understand that this really is quite simple. Okay. At this point right here, this is about them. This is right here is basically a test question. Okay. I'll give you all of that very information right there. Okay. I'm going to ask you these three things. What is the maximum height, range, the maximum time? Okay. The sine of theta, you guys might have seen this in geometry. Some of you guys have been in geometry. Some of you guys are in geometry right now. This is simply an idea that comes from looking at triangles. Okay? The sine of this angle is the opposite over the hypotenuse. Okay? That's not testable information, but I want you guys to understand where that comes from. Okay? So what they're looking at, they're saying is that this angle right here, the sine of that angle is the hypotenuse and the rise as it gains that direction. Okay? So what we're going to do with it is we're going to pop it into a calculator. Just the way it is. Oh, sorry there. It's a T max is equal to 2 V naught sine theta over G, which is just simply 2 times 12 meters per second times the sine of 45 divided by 9.81 meters per second squared. Okay? Any questions about that at all? We're going to amp it up now. Just a little bit. Let's take a look at the maximum height. Okay? And what I'm going to do is I'm going to write this in the exact way that you guys are going to need to put it into a calculator. Parentheses and all. Okay? So H is equal to, well, let's start out with the equation. V naught squared sine squared theta over 2G, which is equal to 12 meters per second squared sine of 45 squared over 2 times 9.81 meters per second squared. One of the things I wanted to make sure to point out to you guys is let's take a look. What is the expected type of unit to come from the maximum height? What should we expect to come out? What are the units of height? Meters. Good. What other kind of units can you expect from height? If it wasn't this problem, we were talking about height. How tall are you? 5'8" what? What does 5 mean?
5 feet.
5 feet. Feet's obviously a unit of height, right? What else is a unit of height? Cool. What else? Meters. What else? What else?
Miles.
What else?
Kilometers.
Kilometers. Nice. Everybody's good. All right. So in this particular problem, we expect there to be meters left over. In order to check our work, let's take a look at what we've done and where we've done it. So we've got seconds squared here. Seconds are going to be squared, so they can cancel. There are meters here. There's meters squared up here. So what that's going to do is you're going to cancel one of them. So you are in fact left with just meters on the board. Okay? Just to check to make sure that we have the things in the right place. Any questions about that? You guys ready to see the third problem now?
Yep.
Word. I'm going to do the third problem right here on this side of the board. It's going to say that the range, or delta x max, is equal to v squared sine 2 theta okay? So the 2 theta part might throw you guys off. Yeah. This 2 theta might throw you off. What is 2 times 45? The sine of 90, just to throw this one at you guys, is 1. Sine of 90 is 1. Makes things really easy. So this effectively becomes v squared over g. I won't make it this easy for you guys. Come the test, I might throw 30 degrees at you. Okay? Just to let you know. Yes, ma'am. Thomas. Just kidding. So many. So many. Yeah.
I didn't hear what you said. What is always 1? What is always
Sine of 90. This is a unit circle type question. The sine of 90 is 1. Just like the cosine of 0 is 1. Not that you need to know the other one. When you guys get into trigonometry, this is the kind of stuff that you guys will be learning there. So it's called the unit circle. And the differences between sines, cosines, tangent, cotangent, etc., etc. All right? Any other questions I can answer for you guys right now? Hey, Aiden, do me a favor. Help him out.
Kevin, bro, we good.
Kevin, how you doing there? Just seeing if the back of your eyelids still got dark? Angle. Theta is the Greek symbol for angle. Change in. Delta is the Greek symbol that we use to say the change in. For example, the change in x, if you look at your graph, the xy coordinates for on a Cartesian plane, you say the change in x, you're saying the change in horizontal position. The change in y is the vertical change in position. Okay? Any other questions that we can get through? Great. Today, guys, we're going to step outside. We're going to go launch some of these 2-liter bottles. Hey, Utica. Utica. Mind do me a favor? Pass these out. Yo, I need you to stop distracting so many people. I know they're easy.
Hey. No cursing on video.
Great. So today, the first thing I want you guys to do is in your groups. There's only 3 people in that back group right there.
Shut it.
Yeah.